Alright, hello, welcome. In this video I'm going to be recording solutions for BC Review number 5, and this is a free response, no calculator review. This is the one where there's like 8 questions and I told you to choose 3 of them. Okay, so I'm just going to kind of go in the order that they're listed here, and it starts off with number 1, which is the family of functions. This is like, this is a question about techniques of integration. So number 1, f of x is equal to 1 over x squared plus bx plus c, but I'll just start in on A. If b is negative 2, f of x is 1 over x squared minus 2x plus c. Okay, and they're going to ask me to find the value of c where the slope of the line tangent to the graph of f at x equals 0 is 6. So I need f prime of 0 equals 6. And in order to find f prime of x, I'm going to rewrite this as x squared minus 2x plus c to the negative first power. Okay, so f prime of x is going to be the negative of that thing to the negative 2. I'm going to use the power rule. And then the chain rule, I'm going to multiply by the derivative of the inside. So x squared minus 2x plus c to the negative 2 power times the derivative of x squared minus 2x plus c is going to be 2x minus 2. F prime of 0, which I know is eventually going to have to equal 6, is going to be the negative of c to the negative 2 times 0 minus 2, and that needs to equal 6. So what I'm going to do is I'm going to divide by 2, right, because I've really got a 2 here with a negative. So I'll have c to the negative 2 equals 3, and that gives me that c is equal to 3 to the negative half power. Okay. For part B, they are saying if b is negative 6 and c equals 9. Well, if that's the case, then f of x is 1 over x squared minus 6x plus 9, which, okay, wait, this is x minus 3 squared. Okay, so I might actually call this x minus 3 to the negative 2 power. Take the integral of f from 0 to 3, well, that's going to become an improper integral. And you know that because it says, or state that it diverges. Okay, well, that means that it's improper. And why is it improper? It's because if I plug in 3, one of the bounds of integration, I'm going to get a division by 0. Okay? And as you might recall, that doesn't always mean that our integral fails to exist, right? We have to consider a limit of an integral. So the integral from 0 to 3 of f is going to be equal to, well, I can find an antiderivative of this. That's going to be the negative of x minus 3 to the negative 1. And then I'm going to have to consider this as we go from 0, not up to 3, but maybe to some a. And I'm going to consider what happens as a approaches 3 from the negative side, right? Because I'm going from 0 to 3 over. As I'm approaching, that's approaching from the negative side. All right, so, and maybe negative that to the negative 1 isn't the best way of talking about this, so maybe I'll write it as a fraction. A is not approaching 0, it's approaching 3. Okay, as we approach 3 from the negative side, I have negative 1 over a minus 3 minus negative 1 over 0 minus 3. That limit doesn't exist. So I'm going to clearly say that the integral diverges. Okay. For part C, if b is 1 and c is 0, find the antiderivative of f of x. Okay, well, we can do that. All right, so in this case, I'm going to be saying f is equal to 1 over x squared minus x. Okay, you look at this and you see it's factorable, and the factors are distinct. That should be setting off alarm bells like, oh, I'm going to have to break this down using partial fractions. We can do that. Okay, so I'm going to say 1 over x times x minus 1 is equal to, well, maybe I won't use a and b since we're already talking about a and b in the course of the problem. I'll use m and n. Okay, so m over x minus 1 plus n over x. And then I multiply both sides by x and x minus 1 to get rid of the denominators. And I'll have 1 is equal to mx plus n times x minus 1. Okay. And then when I let x equal 0, I will see that 1 is equal to negative 1 times n, so n equals negative 1. And if x is equal to 1, I'll see that m times 1, oh, whoops, didn't realize. Okay, I'm still a little new to having the face on the screen. If x is equal to 1, then I'll have m times 1 plus n times 0 equals 1, so that means m equals 1. All right, and then I've got this. I've got it equals, okay, so the integral of the antiderivative of f of x with respect to x is the antiderivative of m is 1 minus 1 over x. Okay, you know how to do this, right? Antiderivative of x minus 1 with respect to x is log absolute value x minus 1. Antiderivative of 1 over x, much the same. Then I'm going to add in a plus c. Okay. Only other thing that you could do here is you could combine these using a log property to become the natural log of the absolute value of x minus 1 divided by x, but that's no more right than this is, and this is just asking you to find an antiderivative, so we're just going to stop there and be happy. All right. For part D, what is part D? If b is 8 and c is equal to 17. This one's nice. Okay, so I've got 1 over x squared plus 8x plus 17. And you look at the denominator, it's like, what am I going to do with this? It's not factorable. Looks like a typo. Okay? And I told you what to do when you see one in the denominator and it looks like a typo. It's like, wait a second, this is wrong. This is just barely off from 1 over x plus 4 squared, right? So I'm going to write this as 1 plus x plus 4 squared, right? Because x plus 4 squared would be x squared, 8x, and 16. And then the antiderivative of 1 over 1 plus u squared is arctangent of u. Okay, so the antiderivative, or the integral from -3 to infinity of f of x dx. And what I could do is I could just be like, okay, I know how to take an antiderivative of this, do that off to the side, and then say this is going to be the limit as x approaches infinity of the antiderivative minus the antiderivative with -3 plugged in. But maybe I'll just do it the way I typically do an improper integral. I'll start by saying this is the limit as the upper bound goes towards infinity of the integral from -3 to b of 1 over 1 plus x plus 4 squared. Okay, this is the limit as b goes towards infinity of arctangent of x plus 4 as x runs from -3 up to b. Okay, which is going to be limit as b approaches infinity if arctangent of b plus 4 minus the arctangent of -3 plus 4. Okay, these are both limits that you are expected to know in Cal BC. Okay, we're expected to know that as the argument goes towards infinity, arctangent gets closer and closer to pi over 2. And then we also need to know what arctangent of 1 is. Think about the most obvious place where on the unit circle where tangent is 1, and that's going to be at pi over 4. Okay, so this is equal to pi over 2 minus pi over 4, which would be pi over 4. You could stop there. Okay, the second one is going to be the Mclaren series. So this is the series question. Maybe I'll just flip this over. All right, so they give you the fact that log of 1 plus x is x minus x squared over 2 plus x to the 3 over 3, and so on. Okay, you could show this by looking at the, what would it be? It would be the Mclaren polynomial for 1 over 1 minus x. You replace x with -x, and then you anti-differentiate, I think, right? And then you'd get this. We could do this for sure, right? Because I'm still barely visible. Okay, and what I want to do right now is I want to just replace x with x over 3, right? Because they say we want to get towards f, and f is x times log of 1 plus x over 3. So the first step is going to replace x with x over 3 wherever I see it. Okay, well, I can do that. Whoops. x over 3. I'm just doing a lot of replacing with x over 3. Okay, I'm going to need parentheses, but I'm going to take x over 3 and I'm going to square it, right? And then over here, I'm going to take it to the third power. So I'm going to have an x over 3 there and an x over 4 here, or x over 3. I'm just replacing x with x over 3. And then over here, I'm going to do the same thing. I'm going to replace x with x over 3. And then, if I wanted to find x, log of 1 plus x over 3, I would just, put in an extra factor of x there, right? And that's a good enough answer for us in this class, for sure. We don't actually need to go through and simplify it and get the general term, a 3 to the n, x to the n plus 1. We don't need that. This is just an expression. Let's go to the first 4 non-zero terms and a general term. We can do that. Okay, determine the interval of convergence of the Mclaren series for f. Show the work that leads to my answer. This is something that we're going to need to maybe do a little bit of simplification later, but maybe not, actually. So for number 2, part B, and I guess if we're going to say that this is equal to the series, then we're going to need a plus dot, dot, dot. And probably mentally we're thinking on its interval of convergence, but if you're not there yet, don't worry. Okay, determine the interval of convergence. When they ask that, you should be thinking, do the ratio test. Okay, we can do the ratio test. So the ratio test is I'm considering the limit as n approaches infinity of an plus 1 over an's absolute value. Okay, just want to declare what am I doing here, just in case I really go off the rails. So I'm going to look at the general term here. Okay, I'm going to copy the general term, but plugging in n plus 1 for n. So negative 1, n plus 2, x times x over 3 to the n plus 1, divide by n plus 1. Divided by or multiplied by the reciprocal of, that's where I'm going to, actually, let me just get over here so I have something to write on. The reciprocal of the original, that's n divided by negative 1 to the n plus 1, x times x over 3 to the n. And I'm taking the absolute value of it, right? So the first thing I want to do is start ignoring these negative 1 to the n's, because I'm taking the absolute value of it anyway. Who cares, right? And then I'm going to cancel off this x with that x, right? And so what I've got n over n plus 1. Those, I'm going to stick those together. And then I can cancel off all but one of these x over 3 to the n plus 1s, right? I've got n of them over here, n plus 1 of them over there. That will leave me with 1 in the numerator. Is equal to the limit as n approaches infinity of n over n plus 1 times x over 3, right? I only have one of them left. This goes to 1 as n goes to infinity, and this does not care what happens as n goes to infinity. So as n goes to infinity, I will have the absolute value of x plus 3, or x divided by 3. And in order for this to converge absolutely, I need the ratio test to come back less than 1. So this means x divided by 3 is less than 1. That means that x over 3, if the absolute value is less than 1, then the thing is between negative 1 and 1. Means kind of the interior of my interval, or my skeleton, is negative 3 to 3. Now I have to check the endpoints. Okay. And so what I want to do here is I'm going to go and, can't see it, but I'm going to grab this, and I'm going to plug in negative 3 for x. Wait, no, this is still 2b. Pardon me. C is an alternating series error bound, which is going to seem really nice in comparison. Okay, so at x equals negative 3, what I will have is a sum from 0 to infinity of, let's see, negative 1 to the n plus 1 times negative 3 times negative 3 over 3 to the n over n. Okay, what's going to happen is negative 1 to the n plus 1 is the opposite, right? So this is always negative 1. You could look at this as negative 1 to the 2n plus 1. 2n plus 1 is always an odd number, so negative 1 to the 2n plus 1 is always negative 1. Negative 1 times negative 3 is positive 3. So this is just the sum from 0 to infinity of 3 over n. Or maybe I'll say it's 1 over n. And I'm going to say this diverges because it's the harmonic series. I don't need any justification for the fact that the harmonic series diverges. Everyone knows that. Okay. So then at x equals 3, let's see what's going to happen. I'll have the sum from 0 to infinity of I'll have negative 1 to the n plus 1. Okay, I'll have, it was going to be 3 times 3 divided by 3 is 1 to the n. 1 to the n is always 1, right? So I'm going to just get rid of that. Just completely ignore it. Don't have to worry. Divided by n. Well, that's equal to 3 times the sum from 0 to infinity of negative 1 to the n plus 1 over n. This converges because it's the alternating harmonic series. You could say it converges by the alternating series test, right? The terms are alternating. They are decreasing in size and going towards 0 eventually. But I could just also say this is the alternating harmonic series, and we all know that the alternating harmonic series converges. That's one that we can just say without much justification. So I'm going to say this converges. Alternating harmonic series. All right, and then part C, that's where they're going to ask you about the alternating series error bound. So what I'm going to do is I'm going to actually do some simplification and copy down the first 4 non-zero terms and show you what they're talking about here. So what I want is going to be, that's going to be better. What I want is I'm going to just go over here, and I'm just going to kind of do some simplification. X squared over 3. It's going to be x to the 3 because 2, and then the blue one is 3 over 9, 18. That's what I'm doing. So the first 4 terms is going to be x squared over 3 minus x to the 3rd over 18 plus x to the 4 over, that'll be 3 to the 3rd, and so that'll be 3 to the 4th is 81. Minus, it's going to be an x to the 5 over, 3 to the 4 is 81 times 4 is going to be 324. Okay, and when they talk about P4 of x, what they mean is the 4th degree Mclaren polynomial. And what that does is that's going to just stop at degree 4. Okay. So if we were trying to find the value of f of 2 using P4, we could just plug in 2 here. And the maximum possible error in that approximation would be the first neglected term, or at least the size of the first neglected term, right? So the maximum possible value of the difference between P4 of x, specifically P4 of 2, right, and f of 2, well, an upper bound for it would be the value of the absolute value of the next term, just with 2 plugged in. Negative 2 to the 5 over 324. And then we can just stop there. That's a number, right? We don't have to take that any farther. Okay, and that's number 2. Okay, it looks like I've got some people about to come in, so I'm gonna pause recording for a second and I'll be back. All right, I'm back. It's much later in the afternoon, but okay, let's get at the area volume one. So, all right, so the area volume one is 3A. Find the area of region R. All right, so it doesn't tell you which one's G and which one's H, but based on the y-intercept, just like G of 0 looks like it needs to be 1. So G is going to be on bottom and H is going to be on top. So this area is going to be the integral from 0 to 2 of h of x minus g of x dx. But when I did this problem earlier, I made an error. And so what I'm going to do is I'm going to split this off into the integral of h of x minus the integral of g of x, and maybe then I will be able to keep myself from making an error. Oh, actually, no, I remember. I think it would have been fine. I just made a copy error. The x minus 1 in h of x became x plus 1 over the course of my work, and so I was very wrong. I had a negative number for the area. I knew that was not right. So what I'm going to do, but I might still do this separately. H of x is, what is h of x? 6 minus 2 times x minus 1 squared. Right? I can do an antiderivative for that, right? I can say that's going to be 6x minus 2/3 of x minus 1 to the third, evaluated from 0 to 2. And then I'm going to subtract the integral from 0 to 2 of the other one is negative 2 plus 3 cosine of pi over 2x. Minus, okay, and then, well, this will be, just like, so some good grouping symbols here. Maybe I'll use negative 2x, and then this would be antiderivative for cosine is regular sine, so plus 3. Oh, but then I'm going to have to deal with this pi over 2. So I'm going to multiply by 2 over pi, right, to prepare for when the pi over 2 comes out for the chain rule. So that will become 6 over pi times the sine of pi over 2x as x runs from 0 to 2. And this is going to be where I'm going to be able to stop, right? As soon as I plug in the 2's and the 0's and the 2's and the 0's over here, I've got myself a good answer, safe place to stop. This would be 12 minus, when I plug in 2, that'd be 12 minus 2/3. Minus, when I plug in 0, I'll have 0 minus 2/3 times negative 1, so maybe that'll be plus 2/3. Make sure that's true. 0 minus 2/3 times negative 1, yeah. Minus, and then over here I'll have negative 4, and then sine of pi is 0. Minus, and then when x is 0, I'll have 0 plus sine of 0, also 0, and that's going to be where I'm going to stop. Okay, this is a positive number. Yeah, because this is 12 minus 4/3, but then adding 4 back, right? So this is certainly a positive number. All right. Region R is the base of a solid. For the solid, at each section, or at each x, the cross-section perpendicular to the x-axis has area A of x is 1 over x plus 3. Okay, what's the volume of the thing? Well, I don't know what kind of shape is going to give you area equals 1 over x plus 3, but I imagine it's not a regular shape. And I don't really have to worry about it, because think about when we have cross-sections perpendicular to the x-axis are squares, what we do is we use a formula for the square, right, to get a formula for the area at that x value, area of the cross-section at that x value. Well, they already gave us the formula, so volume is just the integral of area with respect to, we're cutting against the x-axis, so it's going to be from 0 to 2. It seems too easy, it seems too good to be true. But I know an antiderivative for 1 over x plus 3. That's log absolute value of x plus 3 as x runs from 0 up to 2. And so that would be, like the log of 5 minus the log of 3. You could say that's the log of 5/3 if you want, but you don't have to. Let's see, 3c, right, but don't evaluate an integral expression that gives the volume of the solid generated when r is rotated around the line y equals 6. We need to draw a picture here. All right. So, let me just see if I can give that a little bit. And it does go below the axis. Maybe I'll draw it like that. And, it just wants to go like that. That's the region. Looks like we're trying to rotate around 6, which is either, oh yeah, that is the very top here. What I'm going to do, I'm not going to worry about that. I'm going to actually draw the axis as if it's like well above. Right, this is going to be the axis of rotation. And sometimes I draw these things a little exaggerated, just to give you a better picture of what's going on. Okay, so my large radius here, right, reaching from the axis of rotation to the far side of the region we're rotating, that's my large radius. Large radius, top minus bottom, is y equals 6 minus y equals g of x. And then my small radius is going to reach from the axis of rotation to the near side of the region I'm rotating. And that will be b, which is going to be top minus bottom, y equals 6 minus y equals h of x. Okay. And in conclusion, my volume, we know how to find volume in a washer situation. Volume is pi times the integral. Okay, we're going to be rotating around a horizontal axis that's like the x-axis. So I'll be integrating from x equals 0 to x equals 2 of a squared minus b squared. Now, if you're very explicit, like let a equals 6 minus g of x and b equals 6 minus h of x, then you can say a and b, but I might just copy it this way, right? 6 minus g of x squared minus 6 minus h of x squared dx. And that's me writing but not evaluating an expression involving an integral that gives the volume after you rotate.
Writing g of x and h of x instead of the actual function? Okay.
Yes, that's completely fine, because in the statement of the question, they defined g of x and h of x for you. Yeah. All right, let's do the related rate now. No, wait, no. Okay, so move that over here. All right, related rate. Cylindrical barrel, diameter 2 feet across, collected rainwater. As shown in the figure above. Water drains out through a valve, okay, dH dt. So, okay, depends entirely on age. That's cool. We'll be able to solve that using separation variables, which, yeah, that's part C. H is measured in feet and T is measured in seconds. And they gave you the volume of a cylinder. Well, that might be helpful. Rate of change of the volume of water in the barrel with respect to time when the height of the water is 4 feet. Okay, yeah. So V is pi r squared h. R is constant throughout the whole cylinder as 1. Okay, meaning V is pi times h, and dV dt is going to be pi times dH dt. This is a pretty nice related rate scenario. I like this one. Okay. Then, well, I want to find dV dt, find the rate of change of the volume in the water with respect to time. So I need to say, what is dH dt? Well, I've got a formula for dH dt. So they say at the time when h is equal to 4 feet, right? Yeah, 4 feet. And that's going to be negative 1/10 of the square root of 4. So it feels like negative 2/10 or negative 1/5 to me. Okay? And, well, dV dt is going to be negative 1/5 of pi. So negative pi over 5. We need to indicate units of measure. I'm sure, yeah. Okay, so volume, if h is measured in feet, then volume will be measured in cubic feet. And if t is measured in seconds, dV dt will be cubic feet per second. Yeah. All right. When the height of the water is 3 feet, is the rate of change of the height of the water with respect to time increasing or decreasing? All right, that is an interesting question. I just needed a second to think about that one, I think. Well, like, what am I doing here? So, yeah, this one's a little subtle. So they're saying, is the rate of change increasing or decreasing? Rate of change, that's dH dt, right? Rate of change of height. Now, if we're determining if a thing is increasing or decreasing, what we're going to do is we're going to take its derivative and see if it's positive or negative, right? So we're going to take the derivative of dH dt with respect to time. So derivative with respect to time of dH dt, that's going to be the same as taking the derivative with respect to time of -1/10 of h to the 1/2 power. Okay, whatever. I can do this. Well, it'll be 1/2 of -10th, it'd be -1/20th, h to the -1/2 times dH dt. Okay, well, I don't know. We can plug in on this and see if it's positive or negative. Okay, so when the height of the water is 3 feet, okay, so we know that h is equal to 3. So at h equals 3, I've got -1/20th times 3 to the -1/2. That's interesting. That's a weird number that's come up twice in this problem set, right? 1 over the square root of 3, that's just not what you would expect. And then dH dt is something I'm going to have to think about. It's going to be -1/10 of the square root of 3. And I'm seeing negative times a negative is a positive times a positive times a positive is greater than 0. The rate is increasing. When h is equal to 3. Let me just real quickly look at the scoring guidelines and make sure I'm not like way off. All right, yeah, that's pretty much exactly what they did. Except they actually went through and found what that was. So, yeah, but 3 to the -1/2 times 3 to the 1/2 is 1. I see it now. It's 1 over 200. Yeah, you can actually do that computation in your head if you need. But I don't think you need to. So for C is, what was I thinking? Oh, that's the separation of variables. So just like find h of t. And they give you an initial condition. So what I'm going to do is I'm going to say, okay, I'll start with dH dt is -1/10 of the square root of h. 1 over the square root of h, or h to the -1/2 power dh, is equal to -1/10 of dt. Okay, anti-differentiate, bump up the power by 1, divide by the new power, that's equal to -1/10 of t plus c, divide by 2, square both sides. This is pretty nice as separation of variables goes. Okay, then I'm going to use my initial condition. Say that when time is 0, h is 5. So I've got 5 equals -1/20th of 0 plus c squared. That's telling me that c is equal to, that's interesting, the square root of 5. Why can't it be minus the square root of 5? There's got to be some reason. Hold on, this is one I might have to pause and think about and come back. So h of t is going to be equal to -1/20th of t plus the square root of 5 squared. Okay, yeah, let's dig. All right, yeah, if we look higher up, if we were to try to find out what the plus c was, say at this step or up here, what we would see is that h is a positive number, right? So we would have h to the 1/2 is equal to 0 plus c, and so c would need to be that positive number because h to the 1/2 is that positive number. So that's why I'm going to use the positive square root of 5, and then I think that's probably enough. I'm going to just move on. Number 5. Okay, I'm going to flip over to the back side. Polar, all right. All right. So for 5a, let R be the shaded region that's inside the graph of R equals 4 and also outside the graph of R equals 3 plus 2 cosine theta, as shown in the figure, which I'll just show you here for a second. What I need to point out to you is when you start here at the pole and you reach out to the far edge of the region you're interested in, you hit both curves. And that's where we're going to need to use like the difference of two integrals. We're going to need to subtract inside the integral. So this area is equal to 1/2 the integral from theta 1. They tell you what the two theta values are. It's pi over 3 and 5 pi over 3. That's not what I wanted to say. Start at pi over 3 and we'll run all the way to 5 pi over 3. And the big one, the outside one, is going to be the circle. That's r equals 4. And the inner one is the, I believe that's a limaçon. That's 3 plus 2 cosine theta. But luckily, you know, knowing the names of various polar curves is not part of the AP Calculus class, so you don't have to worry about what that thing is or isn't. Okay, find the write an expression. Wait, okay, yeah. We wrote an expression involving an integral that gave the area of r. Find the slope of the line tangent to the graph of that at x equals pi over 2. We can definitely do that. Okay, what we know is that dy dx is equal to dy d theta over dx d theta, where x is equal to r cosine theta and y is equal to r sine theta. So y is r sine theta. R is 3 plus 2 cosine theta. So 3 sine theta plus 2 sine theta cosine theta. I'm going to quickly take the derivative. Right, I've got product rule going on here. And then when I plug in pi over 2, I'll have, well, cosine of pi over 2 is 0, so that's promising. I'll have negative 2. Okay. Then I'll work on x. X is 3 cosine theta plus 2 cosine theta, which I could write as cosine squared theta. And then I can take the derivative of x. X prime is going to be negative 3 sine theta plus 4, power rule first, 4 cosine theta times negative sine theta. Okay, x prime of pi over 2 is equal to negative 3 plus, well, that's got a cosine in it, so it's going to go to 0. So that's negative 3. And so, as a result, I'm going to say that dy dx at the point where theta is pi over 2 is going to be equal to y prime over x prime. Okay. And then part C. I've got a new shiny technique for dealing with this particle moves along a polar curve situation. I am going to take the derivative of r of theta implicitly with respect to time, and this is just so much better than anything I've done in the past. This is the way to go. So I've got r equals 3 plus 2 cosine theta. And yeah, we're going to move with respect to time in such a way that the distance between the particle and the origin, that's r, increases 3 per second. Okay. Well, I've got dr dt. They want me to find d theta dt, and they're giving me theta. Okay, so I've got everything I need, right? I just need to take the derivative with respect to time. So dr dt, the derivative of 3 with respect to time is still going to be 0, right? And then the derivative of 2 cosine theta is negative 2 sine theta, and theta has its own derivative with respect to time for the chain rule. Okay, and now they've told me that dr dt is 3 and theta is, hold on, it's pi over 3. So dr dt, oh wait, no, 3 equals negative 2. Sine of pi over 3 is root 3 over 2. And then d theta dt is what I'm hoping to find. Okay, so I can just kind of solve for it. Maybe by just saying 3 over, oh hey look, negative square root 3. That's the same as the negative square root of 3 if you wanted to keep going. But wait a second, I feel like wasn't there one of these where it's asking, yeah, indicate units of measure. Okay, so what is the measure of theta? That's going to be in radians. t is measured in, I don't even know, seconds. Yeah, thank you. So yeah, radians per second, right? Units of theta divided by units of t. Units of dependent variable divided by units of independent variable. All right, number 6, graph of derivative. We love this one, or we should. I hope you love this one at this point, because that's just one of the few guarantees is that you're going to see one of these on your AP exam, and well, hopefully you're going to be good at it because you had plenty of opportunity to practice it. So find the values of f of -6 and f of 5. Okay, man. Okay. They gave you f of -2 equals 7. So I'm going to use f of b as f of a plus the integral from a to b of f prime of x dx. Okay. And that's equal to 7, but this is backwards, so minus the integral from -6 to -2 of f prime. And that's 7 minus, and that's a triangle, so 1/2 times 4 times 2. And I'm going to stop there. F of 5. Now, because I've done this problem already once, I know I'm going to actually need that number eventually, but I'll deal with that when I need it. F of 5 equals f of -2 plus the integral from -2 to 5 of f prime of x. Okay. Which would be 7 plus, okay, the first part is that, that half circle that sits underneath the x-axis, which is looking like it has area 2 pi. So I'll have -2 pi. And then I'll add in this triangle, and let's say 1/2. Base looks like 3 units. Height looks like 2 units. And then I'll just stop, right? And that's f of -6 and f of 5. Okay. On what intervals is f increasing? Yes, please. I would love to do that problem. 6b. F is increasing anytime f prime is positive, but they gave us a picture of f prime. F is increasing for -6 to, what is it, -2, and 2 to 5. And how do I know this? Because f prime is positive. And that's all you got to say. Find the absolute minimum value of f on the closed interval -6 to 5. Okay. The absolute minimum, well, if I'm going to try to maximize something or minimize it, I need to figure out where its derivative is equal to 0. Okay. And then I need to check these in the critical points to figure out which one is the minimum. So I'll say f of -6. I already have that. I'm going to also be interested in f of -2. I'll be interested in f of 2, and I'll be interested in f of 5. But I've already got half of these, right? Just need to go back up here and say f of -6 is 7 minus 4, which is 3. Wait, is that it? 1/2 times 4 times 7 minus 4 is 3, yeah. Okay. That's just, I feel like that's not what I had earlier. Is that the right number? Is that the right amount of, the right count? I guess I don't even have the copy. Who knows, whatever. I'll just double check this against scoring guidelines in a second. F of -2 they told me is 7. F of 2 I'm not sure about. Oh, that's going to be 7 minus 2 pi, right? Because I'm going to start here at 7, and then I'm going to go over here to 2, and that's going to subtract the 2 pi. And then f of 5, we already found that. That's 7 plus 3 is 10 minus 2 pi. Okay, based on this, I feel like this has got to be the smallest one, because that's pretty close to 0. So minimum value of f on the interval -6 to 5 is f of 2 equals 7 minus 2 pi. And that's, oh, and you can't see that because of my face being in the way, but there you go. Okay. Now, part D is a little, it's a little subtle. And I want to talk to you about, like, how are we going to explain that? Because I think that you can, pretty easily see that the slope at -5, so f double prime of -5, I'm going to do rise over run on that line segment that's over there on the far left side. So that would be 0 minus 2 over -2 minus -6. y2 minus y1 over x2 minus x1. Okay, and that's going to be a safe place for me to stop. Okay, but f double prime of 3 is not going to exist because of a sharp corner. Now, I think that it's interesting. I don't know. I looked at the scoring guidelines for this one. I don't know if you were allowed to say because of the sharp corner. I suspect that you would. That would be okay. If you really want to give it in terms of like a mathematical reason, what you're going to want to do is you're going to want to talk about the limit of the slope from the left and the limit of the slope from the right, and that they're not equal. Okay. And what is the slope of you're looking at the graph of f prime. So the issue here is the limit as x approaches 3 of f prime of x minus f prime of 3 over x minus 3. That doesn't exist because the limit from the left is not equal to the limit from the right. And this rise over run difference quotient is one of the things, for those of y'all that are sitting here in person, that I wanted to put on our note sheet and I didn't. And so, I don't know, if you've made it this far in this video, and I'm 45 minutes in, I put in some limit definitions onto my sheet. You need to know that a continuous function means the limit of f of x is f of c, right? The limit as x approaches c of f of x is f of c. It equals what you expect it to be. The derivative, there's kind of two different limit of a difference quotient that you have to worry about. Okay, that's the value of f prime of c. And then there's the number e. The definition of the number e, this is the definition that we take in Mclaren. And I mean, the likelihood of you being asked about this is very, very low. But within reason, kind of like the integral being the limit of the Riemann sum, I am obligated to tell you about it and show you some of the problems. I don't think I know of any problems that utilize this fact in AP Calculus. But I do know of a couple of integrals, the limit of the Riemann sum, multiple choice questions. And just hold on, I'll give you those in a couple of weeks. You don't need them yet. Okay, so there was this. This was cool. This is number 6. I've got 2 more. I can do it. All right, miscellaneous and unexpected. Now, I had to make sure to give you one that was a little weird because you're going to sit down in a few weeks and you're going to take your AP exam and there's going to be something weird on it, right? You can't control that. That's always going to happen. So we need to just expect the unexpected and just practice it. So this was just a bizarre function that they started with partial fractions so that they could, ask you some questions, and they worked backwards from it. So f is 3 over x squared minus, or 2x squared minus 7x plus 5. X squared minus 7x plus 5 to the negative 1. All right, what I'm going to do, if they want the slope of the line tangent of the graph of f at x equals 3, I need to take the derivative and I need to plug in 3. So I'm going to write this instead of a fraction, write it as just a power. And so I'm going to say f prime of x is going to be equal to negative 3 times this to the negative 2 times the derivative of the inside. That would be 4x minus 7. Okay, then f prime of 3 is going to be, f prime of 3 is negative 3 times 2 times negative 3 squared minus 7 times negative 3 plus 5, all to the negative 2 times 4 times negative 3 minus 7. Yeah, it's actually equal to 3. I don't know why. I think it must have been because of that negative 3. I thought I had to plug it in, but okay, that it won't matter there. This it will. Here it certainly will also. Oh, goodness. Yeah, that's what it's supposed to be. All right, find the x-coordinate of each critical point of f on the interval 1 to 2.5. Interesting. All right, well, the thing is, oh, I get it. Critical point is derivative equals 0 or derivative is undefined. Now, I think I'm going to have a place where the derivative is undefined on this one. I haven't worked this one all the way through. I just saw this one this morning when I was compiling problems. I was like, oh, this one's weird. I think I've given people the part C and D before, maybe on a test in previous years. But okay, I'm going to rewrite f prime of x as a fraction. And I'm going to factor out that negative 3 because it's not going to contribute anything to me. So I've got 4x minus 7. And then I've also got 2x squared minus 7x plus 5. But I'm going to look ahead in the question, right? You should always read the full question before you start it. Because they showed you how to factor that thing. They showed you that 2x squared minus 7x plus 5. And I assume you probably know how to factor this, but who knows? Maybe you don't. I know that was something they were really bad at when I taught pre-cal, was factoring when the leading coefficient was not 1. They could find the zeros, but they could never find the factors because of some trick that they'd been given by some algebra teacher along the way that not only didn't help them, it actively hurt them later on. So there we go. All right, cool. We've got it in factored form. So my critical points. Do I have to classify these as maximum, minimum, or neither? Wow. Yes, question. Oh, yeah, good point. Yes, it will be squared, and that will help my sign analysis quite a bit, because that means the denominator is always positive. Yeah, good point. Thank you. That would have really made my I think. All right, critical points are going to be x equals 7/4 from the numerator equaling 0. And they said bigger than 1 and less than 2.5. So I don't have to worry about either of these, right? Because that's the exterior of the or the boundary of the interval. I'm only interested in between that. Okay? I might just to remind the reader that I know what I'm doing, that these are critical points, but I'm going to ignore them because they're outside of the interval I'm interested in. Thank you. Thank you, AP exam question writer. That was really generous. Wasn't really looking forward to that part. Okay, so let's look at before and after 7/4. What is 7/4? That's like 1.75. Either way, what I'll do is I will just choose like 1.5 here. All right, 4 times 1.5 is 6. So 6 minus 7 is negative. This denominator has to be positive. So I've got negative, negative makes a positive, with positive, that is in total positive. And I'm hoping that with this type of analysis, somebody would catch me in person if I was going to make an error here. And I feel like because of this being just first degree, that's going to switch over to negative. Now to make sure, I'm going to plug in x equals 2. And I'm going to say negative 3 times 8 minus 7 is 1. Yeah, so I got negative, positive, positive. Okay, cool. So what I'm going to do is, and this is important to remember, that you've got to remember that this whole thing that I'm boxing in red, it's like the AP exam reader, it's like they're magically blind to that. They cannot see that. You wrote it there, but it's not really there. They're not going to judge, they're not going to give you any credit based on that. They're also not going to take away any credit based on that either. But yeah, sign chart's not justification and not something that the reader is just going to look at really at all. They're just going to ignore it. But I'm going to say x equals 7/4 is the location of a relative maximum what kind of language were they using? Relative maximum. Because f prime is positive on 1 to 1.75, and they know that 7/4 is 1.75, and f prime is negative on 1.75 to 2.5. Okay, now you can say f prime is positive. F prime changes from positive to negative at x equals 1.75. That might actually be a better way to write that. I just didn't. And that works also. Yes?
The question, it says like find the x coordinate of a critical point and use a critical point. So do we have to like explicitly say that x given is also a critical point?
No, because, okay, so if you, I mean, that was what I did here when I wrote down the critical points were these three and I crossed them out. I really think that if you just started your discussion with x equals 7/4, if here's f prime, x equals 7/4 is going to be a relative maximum with the before and after analysis. I think that's going to be good enough. Let's look at the scoring guidelines real quick. I can't show them to you because I don't have them printed out on a sheet of paper, but hold on a second. I'm going to go peek at them, pause the recording. All right, yeah, it was 1 point for identifying x equals 7/4 and 1 point for maximum with reason. So, not as harsh as we expected. Okay, using the identity where they already did the partial fractions for you, compute the integral from 5 to infinity of f of x. Okay, well, we can do that. Actually, what I'm going to do, like we could do this by transforming into a limit of an integral, right? And that's what I did, I think, the last improper integral I had to do in this video. But what I'm going to do instead is I'm going to go over here, and I'm going to just find an antiderivative for 2 over 2x minus 5 minus 1 over x minus 1. Okay, so that's 1 log of the absolute value of 2x minus 5. And I need you to sit there and take a second and be like, wait, why is that 1 log? Shouldn't it be 2 logs? No, it'd be 1 log because when I take the derivative, it would be 1 over 2x minus 5 times the 2 for the chain rule. Gets me exactly what I have there. Okay, minus the log of the absolute value of x minus 1 plus c. That's going to be an antiderivative, right? Well, I can rewrite that as the log of a ratio. That's going to be 2x minus 5 over x minus 1, and then plus c. But, okay, since I'm doing a definite integral, the c, I don't need to worry about it, right? It's going to get subtracted away, okay? I just don't want you to, screen clip me saying like, oh, this is equal to that without the plus c, and say, oh, you're such a dummy, you forget your constant of integration. I am a dummy. I do forget my constant of integration, but not right now. So, what I want to do is the integral from 5 to infinity of f of x dx. Well, that's going to be the limit of this thing as x goes to infinity minus this thing with 5 plugged in. So on one hand, I've got limit as x approaches infinity of log absolute value 2x minus 5 over x minus 1. Okay, as x goes to infinity, the thing in the absolute values is going to go closer and closer to 2, so I'm getting closer to taking the log of 2. And if I plug in 5, I'll have 10 minus 5 on the numerator and 5 minus 1 in the denominator. So, and I need to evaluate that limit. That's going to be log of 2 minus the log of 5/4. And I don't need to do anything else there. You can combine those, 2 divided by 5/4, 8/5, maybe. Why worry about it, right? Just move on and do part D. All right, now for part D, you've got a couple of options. I don't know what y'all would be more likely to think. I'd say if you just had success on part C and you just ran that improper integral, hopefully you're saying, I'm going to use the integral test. But maybe you forgot the conditions for the integral test, right? Okay, I'll do this 2 different ways. I'll do the integral test and then I'll do the limit comparison. Limit comparison is great because you look at it and you see it's bigger on bottom by 2 powers, right? And I really think that's probably like closer to home for us. And so just remember that you just need to say that 1 over n squared converges by the p-series test. The limit is positive and finite, therefore it's going to have the same behavior. In the scoring guidelines, you'll see they verified that both series were positive, but if they weren't both positive, then they're limited their ratio. I really don't think they would bother you on that. I don't think they'd charge you for not mentioning that both series were positive before using the limit comparison test. Hold on a second. All right, back to it. So the series is going to converge because it's bigger on bottom by more than 1. right? But I'll say that f is continuous, positive, and decreasing at least for x greater than 5. And honestly, I'm just going to assume that because the integral came back finite. Right, I'm within reason it's probably going to be positive because the numerator is positive, the denominator is something that's going to be getting bigger and bigger over time. So just take that on faith. It's true. So, and I just know that I just showed that the integral from 5 to infinity of f, therefore, I know that the sum from 5 to infinity of f of n also converges. Right, it's an if and only if too. So if that had diverged, I would know the other one. If the integral had diverged, I would know that the sum had diverged. Alternatively, I could say, let's see. Let's compare with limit comparison with 1 over n squared. 1 over n squared as n runs from 1 to infinity. Converges by the p-series test. Also, the limit as n approaches infinity of f of n divided by 1 over n squared, but I can actually do that. I'm just going to find it. 3 over 2n squared minus 7n plus 5 divided by 1 over n squared, so times n squared over 1, is equal to 3 over 2. The limit is positive and finite. Therefore, much like the sum from 1 to infinity of 1 over n squared, the sum from 5 to infinity of f of n converges. Right? Don't need to say I'm using the limit comparison test. You just need to do the limit comparison test, and because they requested, state the conditions of the test. Right? Well, that limit is positive and finite. Now, for number 8, the differential equation. This one's actually really nice. I like this one a lot. It was pretty friendly to us. Okay, I found a sheet that I can just write on the back. All right. So, number 8. Okay, here we go. All right, so for number 8, that's the differential equation. All right, so dy dx is equal to x squared minus half of y. And this is one that I think a lot of people did in my class today, but no, we didn't discuss it. The most I got out of anybody was like, hey, how far am I supposed to go with part A? And then it turned out that she had gotten the right amount of distance. So 8a is find the second derivative of y with respect to x both times in terms of x and y only. Or it just says in terms of x and y. But okay, that's the derivative with respect to x of dy dx. So that's x squared minus half y. Then I'm going to take the derivative of with respect to x. Derivative of x squared with respect to x is 2x. The derivative of half of y is half of dy dx. But they want it in terms of x and y. So 2x minus half of dy dx was x squared minus half of y. And I'll just leave it there, right? Okay, let y equals f be the particular solution to the given differential equation, which is not separable, right? If you want to find out what the solution is, you need to take my differential equations class. Okay, but in this class, we can't find that solution, right? That's what they want you to do, right? Is try to do separation of variables. It's not possible. We don't have any other techniques here, so you'd be floundering. None of these are going to involve separation of variables. Okay, the graph passes through -2, 8. So f of negative 2 equals 8. Seems like a good thing to write down there. Is there a relative maximum, minimum, or neither at the point negative 2, 8, and justify my answer? Well, I'm going to hope that I plug it into dy dx and it comes back non-zero, and I can say neither. But somehow I don't think so. Dy dx at negative 2, 8 is equal to negative 2 squared is 4 minus half of 8 is 4, which is 0. Okay, this is possibly a maximum or a minimum. In fact, I know it's going to be one or the other because all we can do here is the second derivative test. And I know that they wouldn't ask it to you in a situation where you had to be like, oh, the second derivative test was inconclusive. I don't know what to say. They wouldn't do that, right? So negative 2, 8, the second derivative, I'm going to actually use this formula, right? That's 2x minus half of dy dx. Well, I know dy dx was 0, so there's no sense in doing that computation twice. So I've got negative 4, which is less than 0. So I'm going to say that since dy dx equals 0 and the second derivative of y on x both times is negative, negative 2, 8 is a relative maximum. All right, for part C, g is the particular solution with g of negative 1 equals 2. Find this limit. Show the work that leads to my answer. All right, well, the limit as x approaches negative 1 of g of x minus 2 over 3 times x plus 1 squared. All right. What I'm going to do, based on what I learned last summer, I'm going to be drawing separate arrows, showing them separately going to 0. This is not really what I would say, but, we'll play the game they want us to play, right? Show them going to 0 separately so I can apply L'Hopital's rule.
Wait, I have a question.
Yes.
Should we do that just to be safe? Or
Yeah, I do. That's what I am recommending, is that if you're going to do L'Hopital's rule, just show the top and bottom are going to 0 separately. At the very least, use an arrow to go to 0 over 0, not equals 0 over 0, based on what we saw. One arrow to 0 over 0, I think that should be fine. Honestly, I think equals 0 over 0, while definitely not a true statement of equality, right? In there, you person watching my video, that 0 over 0 is not a real number, and equals is a relationship that's defined between two real numbers in this class. But I just don't see that as the biggest deal in the world, in the midst of people forgetting their chain rule and, this year not knowing the derivative of cosecant. They're going to pick on you on your style on L'Hopital's rule. I don't really agree with it, but you didn't click on this video to hear about what I agree with and disagree with. You want to know how to solve problems, right? So I'm going to use the L'Hopital's rule, and so this is equal to the limit as x goes to negative 1, derivative of top, derivative of bottom. Oh, what is g prime? At negative 1, 2, yep, that's going to go to 0 over 0 again. Because g prime of x is dy dx, and if you just, it's going to go to 0 over 0. Use L'Hopital again. That's interesting. I like how I had a 2-iteration one here. And that would make sense why they would have had you find the second derivative, right? G double prime of x over 6. Okay, this is going to be something that's equal to something else. All right, g double prime of x. I'm going to have to scroll way back up here. It's 2x minus half of dy dx. Well, I know that dy dx was 0 when at the place I was interested in, so it's just 2x. 2 times negative 1 is negative 2 over 6. And that's where I'm going to stop on this problem, at least. All right, part D. I thought I had enough room. Okay, I just found a scrap of paper. I'm going to just kind of cover this up. And work number 8D. Let h be the particular solution with h of 0 equals 2. Use Euler's method, starting at x equals 0, 2 steps of equal size to approximate h of 1. Okay, we can do that. It's just 2 tangent lines, right? We're just 2 tangent lines away from having done all of these problems, and this has been a marathon, at least for me. I've been leaning on this hand a little too much. It's starting to get sore. All right, so the first one is tangent line 1 point would be 0 and 2. The slope, I need a formula for dy dx. That's x squared minus half of y is -1. All right. Equation is y minus 2 is -1 times x minus 0. I plug in 0.5 to get, y of 0.5 approximately equal to 2 minus 1 times 0.5, all right? So my new point is 0.5. 2 minus a half is 1.5. All right, now I'm going to get I've got my new point, got a new slope, x squared, oh no, minus half. Okay, that's fine. The arithmetic on these weather methods never ends up too bad. And, okay, oh yeah, equation. Y minus 1.5 is equal to -1/2 of x minus 0.5. And then I'm going to approximate y of 1 to be almost 1.5 minus half of, well, 1 minus a half would be 0.5. Double check, did I multiply by the same number here and there? I sure did. Okay, that's good. So half of a half is a quarter. That's 1.25. Let me just make sure that's the number I'm supposed to get. And it is. All right, so that's all 8 of the free response problems from Review 5. I'm just going to ask, if you watched all of this, or if you just watched the differential equation, if this helped you understand any of these, I'm going to ask you to like this video.